Good morning for everybody. First of all, I would like to thank SECPHO for this opportunity to present our technology platform for us PICs to the audience. My name is Jad Sabek. I'm the silicon nitride PICs business developer at the National Microelectronics Center in Barcelona. So our institute belongs to the CSIC, which is the largest public multidisciplinary research organization in Spain. So let me introduce some features of our institution. So the IMB-CNM has an extensive knowledge and experience in the field of silicon technology in general and miniaturized devices-based technology or supported by silicon. Key enabling technologies such as micro, nano electronics, and photonics are part of the technological background developed by our research group of the institution. Moreover, our institute holds the clean room of micro and nano fabrication, an infrastructure with 1,500 square meters clean room space, which makes it the largest clean room in whole Spain, with a large amount of processes managed by our expert team, ensuring very high throughput, reproducibility, and robustness of the development technologies. The main numbers of the institute are according with our research and development mission of industrial support. Thus, the clean room personnel is the same as the number of PhD students, since we have 1-to-1 ratio of researchers to support technicians. Likewise, clean room develops technologies from the concept to the final product. So from TRL 2, which is the concept, to the TRL 9, which is the ready product to the market. And because of the high industrial components in our budget, thus our incomes from industrial sector are more relevant than for other research centers. Well, as mentioned, the clean room infrastructure and equipment allow for the development of processes for the performance and characterization of electronics and photonic micro and nano devices, integrated circuits, and micro nano system intended for research, development, and technology transfer to industry. Moreover, we have the capability to small and medium series production for the dedicated component or circuits. With our clean room, we are a micro nano fabs technology member devoted to micro and nano manufacturing. This network has now become part of the European Network Euro Nanolab as initiative to establish the large-scale distributed nanofabrication research infrastructure. We are also devoted to technology transfer to education, training, dissemination of research results, and also the industrial sector. The mission is to raise awareness and contribute to the implementation of solutions based on micro and nanotechnologies into new products and solutions for solving social challenges. Examples of some devices transferred to industry are present in here. As you can see here, this radiation detectors for the CERN, silicon carbon rectifiers for the European Space Agency, or either some chemical sensing dispositives for the healthcare applications. So also within our clean room is running a photonics platform based on silicon nitride technology as core material with different waveguides geometries and core thicknesses, which allows us to develop photonic components ranging from visible to mid-infrared wavelengths. The silicon nitride fabrication platform is for near-infrared PICs, offers the possibility to fabricate prototypes under a multi-project wafer scheme to share costs with other customers by covering the expenses of only the specific area of the wafer. Well, here we represent the different waveguide structure we offer depending on the final application. These structures and the corresponding technologies and photonic components were developed under collaboration with other groups and companies according with its research or industrial objectives. Should consider also that our technology is silicon nitride based because, as you mentioned before, it offers several advantages compared to other technologies, since silicon nitride doesn't present the two-photon effect. It presents a very low birefringence and it's transparent from visible to mid-infrared. So regarding the wavelength range, our technology is able to be used for telecommunication systems such as wave filters, LiDAR, programmable PICs for near and middle infrared, or for the biosensing, mostly in the visible range. So here you can see how we etch this cladding silicon oxide. So we functionalize the surface guide with the specific chemical receptor in order to selectively detect the required analyte from the whole sample. So within this context, we have developed several PICs fabrication strategies depending on the needs of our customers. Here we show the dedicated process for the silicon nitride PICs. This strategy is recommended to customers with access to licenses and design software by means of their own experts. Let's say such as research institutes, universities, or either for industrialization process companies. And by the fabrication of a large amount of wafers by our technology, it results cost effective. Well, up to date, most of the fabricated batches we have been used to develop our components were in the visible and mid-infrared wavelength ranges. So, but for all customers, a multi-project wafer was developed in order to make silicon nitride PICs nanofabrication even more accessible to everybody, combining the VLT photonics expertise in the design and simulation with our expertise in the nanofabrication. So we cover the whole process from the design to the final conventional packaging. So the multi-project wafer approach consists on the fabrication of the PICs in a batch or fabrication that runs where the wafer surface can share costs with other customers and hence cover the expenses of only the specific area of the chip. Here you have an example in which it is depicted how the chips are included in a reticle layout and fabricated. After the wafers are sewed in different cells or chips and sorted by their sizes, the chips are sent then to the different groups collaborating in the multi-project wafer. So within the multi-project wafer also, and with PLC actuating as our technology broker, the customers have access.
The last minute.
Yeah, sure. Thank you. The customers have access to the process design that includes the kit, which includes also some, let's say, conventional structures such as spirals, reflectors, filters, etc. So finally, if you are interested on developing a PIC circuit and you miss the required nanofabrication facilities, just count on us, your technology, as your technology partner. You have just to contact us, and through our Open Foundry, we will perform a customized strategy to develop your photonic circuits analysis, and we provide the best solutions. Well, thank you very much, and I hope you enjoyed this presentation and you find it interesting. And please, I would like to answer your doubts and questions.
Thank you.